is generative AI is going to have a huge impact on humanity because it solves a lot of knowledge problems, and we're faced with a lot of knowledge problems. Deep reinforcement learning solves operational problems. And on the plant floor, we tend to suffer more from operational problems than actual knowledge problems. So that's where I think that, now, it's not to say that those two things are mutually exclusive. We definitely are exploring these ideas of generative AI working with deep reinforcement learning and how those two could interact.
Growing a business requires a holistic approach that extends beyond sales and marketing. This approach needs alignment among people, processes, and technologies. So if you're a business owner, operations, or finance leader looking to learn growth strategies from your peers and competitors, you're tuned into the right podcast. Welcome to the WBS Podcast, where scalable growth using business systems is our #1 priority. Now, here is your host, Sam Gupta.
Hey everyone, welcome back to another episode of the WBS Podcast. I'm Sam Gupta, your host and principal consultant at the independent ERP and digital transformation consulting firm Elevate IQ. Autonomous AI represents a frontier in artificial intelligence, encompassing a spectrum that differs from predictive and generative capabilities. Distinguishing between these facets, predictive AI anticipates outcomes based on historical data, while generative AI creates new content and scenarios. Autonomous AI, however, takes a leap further by not only predicting but actively making decisions independently. Its potential lies in its ability to autonomously analyze complex datasets, discern patterns, and make informed decisions without constant human intervention. The nuances of autonomous AI extend to advancements like DeepMind and deeper reinforcement learning, pushing the boundaries of machine intelligence. In today's episode, our guest, Brian DuBois, discusses how autonomous AI differs from predictive and generative AI. He also breaks down how and why autonomous AI is especially relevant in the industrial applications. Finally, he sheds light into various issues manufacturers facing today, such as their unwillingness to connect their current equipment to the internet. Let me introduce Brian to you. Brian DuBois is the Director of Industrial AI at WBSP579, one of the largest independent global system integrators focused on manufacturing and industrial customers. During the 20 years he has worked there, he has focused on manufacturing execution systems, historians, plant floor software, and level 3 information solutions in the operational technology space. Brian's current focus is on operationalizing technologies such as artificial intelligence, data infrastructure, and advanced analytics to boost the productivity of global manufacturers. With that, let's get to the conversation. Hey, Brian, welcome to the show.
Yeah, great to be here, Sam.
Of course, and it's my pleasure. And anybody who comes from the Industry 4.0 community, it's always a pleasure. We have done a lot of episodes, Brian, and we have had all sorts of debates from the IT/OT perspective. So it's always very interesting. Both communities are extremely passionate. So just to kick things off, if my listeners might not know you, do you want to provide a quick intro about you as well as what you are focusing on these days?
Yeah, sure can. So my name is Brian DuBois, and I am the Director of Industrial AI at a company called WBSP579. So we are a system integrator, and we target those manufacturing and industrial customers. My background, I've been with WBSP579 for actually 23 years now, and so I've spent my whole professional career in this industrial and manufacturing IT/OT space. And my background, I've got a CS degree from the University of Akron.
Okay, very interesting background. So we definitely are going to have slightly more technical conversation. In general, Brian, I'll give you some insight in terms of the kind of episodes we do here. So for the most part, our community is CFOs, CEOs, and we are generally talking about business a lot more than technology, even though we are sort of both, right? So we will dig into that. But before we do that, we have one of these standard questions that we ask every single guest, and that is going to be your perspective on business growth.
Yeah. Well, and of course, obviously, it's going to be heavily biased by what I do, right? So my focus, my job is about bringing industrial AI solutions to my clients. So I'm pretty biased towards AI from that standpoint, and so my focus is going to be on growing through the adoption of industrial AI. And I think one of the important takeaways for your audience is going to be that while these things may sound kind of futuristic, and I hear from a lot of clients that are like, well, that sounds awesome, like we'll get there eventually, but I don't know that we're ready yet. I think the important takeaway is that there's a lot of steps you can take now to put yourself on a path to an AI future, and that you really should start now, and you should start thinking about that now. One of the things that I've been saying for a while now is that everyone talks about how we're in this fourth industrial revolution, right? And it's interesting because when you're in the middle of a revolution, it's hard to see what the final outcome is going to be. Now, we can look back on the third industrial revolution, the second one, and we can say, okay, it was about this, it was about that. I do believe that the fourth industrial revolution, when we look back, will be about AI. So I've spent my whole career building software solutions, collecting so much data from the plant floor for my customers. And I think that when we get to the end of this thing, we're going to say, oh, we were collecting all that data so that we could empower an AI future for ourselves. I really do think so. So to get to that end goal, we go ahead and start today. There's no reason not to start taking those steps towards an industrial AI future for your company.
Yeah, so very interesting perspective there. So I'm going to provide two layers, and then maybe you can provide some more commentary in terms of what you are hearing in the field, whether companies are really excited about it, they are not excited about it. So most of my control system friends, the real OT friends, they have been struggling to sell even the industrial solution. Okay. Companies are struggling to understand what the hell industrial solutions mean. A lot of machines that they have, they don't even have internet right now.
Right.
And that is the challenge that they are running into. And now we are proposing this AI. I'll give you one more layer there, okay? So I was one of the podcasts myself as a guest. Rootstock is the manufacturing ERP software. I don't know if you are familiar with them, but they do a lot of work in the manufacturing. They did one of the surveys, and in that survey, they interviewed, I guess, 300 to 400 different manufacturers. And they were claiming that, these manufacturers were really excited about AI. And I'm like, okay, I can probably believe that, okay? So now we have two different perspectives. One perspective is, they are really skeptical. They are not even on the actual OT side of the equation, and the another equation is AI. So what's going on here? Maybe reconcile the arguments here, provide your perspective in terms of what you are seeing in the field right now.
Well, okay, so there's a lot to break down there. So the first part is that yes, I do see a lot of excitement, right? So it's actually really easy for me to get meetings with clients because they want to talk about AI. They're excited to hear about what the state of the industry is.
Yeah.
But translating that excitement into kind of actionable projects and things like that, you're right. There's a gap there, and there is a lot of skepticism. And I absolutely agree. I think in certain industries, certain industries are a little further ahead than others. But in certain industries, particularly discrete manufacturing, where you're making like widgets, we tend to say discrete is about making things, not stuff. So stuff like gallons of stuff, that's more the process industry. And those folks have had pretty robust OT data infrastructure for a while. But you're absolutely right. Discrete has been a lot of isolated work cells, a lot of isolated equipment for a long time that you're right, may not be networked at all. So but when I talk about taking that first step, that's really what I'm talking about. I kind of gave it away already. And that's about building an OT data infrastructure. So a lot of times I'm sitting down and talking with these clients, and we're talking about an AI future. But what they can do today is build out that OT data infrastructure. So I tend to say I'm the bearer of bad news a lot of times, because they'll have big ideas and a lot of excitement. But a lot of the folks that I'm talking to at that level may not even realize that their equipment's not networked. So then I have to kind of step backwards and say, okay, guys, but here's a perfect example. So I had a semiconductor manufacturer, and we're talking about AI. They're really excited. They want to do AI. And so but the same thing, they had a bunch of kind of disconnected work cells. Each one had its own little data logger. It was like a SQL data logger. And they said, now, So we're in the Q&A portion of my pitch, and they go, now these AI algorithms, now do they know how to go out and gather all that data from all these different, databases that are connected to all this equipment? I said, no, not even a little.
Right.
Oh, no. We need to pivot, guys.
Yeah.
So then we pivot and we start talking about, well, let's build out an OT data infrastructure to get you guys ready, to actually take advantage of some of these more advanced technologies.
Right. So very interesting perspective. And now I'm going to tell you another very, 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 very interesting perspective. Okay. And your mind is probably going to be blown away. And the reason for that is because we are combining one cutting edge technology as well as one very legacy perspective. Okay. So one legacy perspective is, hey, I'm the manufacturer. I don't trust internet. Okay. I am not going to go online. We have seen that with a lot of clients that we serve.
For sure.
They were like, okay, don't touch my machines. Okay. Do not touch that. Okay, so let's hypothetical scenario that this particular person is really excited about AI for some reason. Okay, and they want to go for AI, but they are not comfortable connecting their machine to internet. Do you see any sort of issues? Can these businesses take advantage of AI? Let's say if they don't want to go, because as such, AI does not need to be connected with the machines. AI algorithms can run wherever. You are simply doing the data reading, doing some magic there from the algo perspective, and then gathering some sort of insights, right? It's not that you have to connect the machine. So do you see any sort of issues there? What do you think of this?
No, I think that there's absolutely a path forward for those folks. And to be honest, that's the majority of my clients that are not interested in connecting their equipment. And I think that that's a message that's not really getting through to some of these IT vendors that are kind of finding their way down into this OT space. Because I see so many of these IT vendors that are like, no, we're just going to put a box out on the plant control network that's going to connect directly to the internet. And the clients, network guys and security guys are like, oh, no, you're not going to do that. No, that's not happening. So the way to solve that is it's actually a problem we solved years ago, decades ago. And that's that the plant control network continues to stay secure. We create what's called a demilitarized zone, or DMZ. And the data from the plant floor flows up into data collectors that exist in that DMZ. And that's a very carefully structured, the security is very tight there. We got firewalls on both sides. And then the business network, which would typically have access to the internet, can only get down into the DMZ and capture that collected data, cannot get down into the plant control network. So a little more technical, kind of description of how that all works. But the idea is that you're still keeping all that equipment isolated from the internet. You're just extracting that data. And that data then is what we can use to go up into the cloud. We can train on it. But here's the other key thing that, again, I see a lot of AI vendors in this OT space that I feel like are missing the boat. They want to kind of close the loop where you're going to send data up in real time to the cloud. Some AI model is going to make decisions, and then you're somehow going to get the decision back down through all those layers and back down into the plant control network, which is supposed to be isolated. To me, that's the wrong approach. What you should be doing is taking all that data. Yes, use the cloud, because a lot of this training is compute intensive, memory intensive. You need to spin up a lot of VMs, maybe hundreds sometimes of VMs in parallel. So train that model. But then what we can do as an OTSI, someone who lives and breathes the plant floor, we can take that OT model and we can operationalize it down into the plant control network, where it's isolated still. It's no longer communicating to the internet, but it's still able to make decisions and then act on them in real time. I think that's the better approach than what we're hearing a lot from some of these vendors.
Yeah, so very interesting. And I know that, see, we were talking in the pre-show as well, and you are fairly deep overall in AI use cases too, right? And one of the terms that you had coined in the conversation is autonomous AI, which I don't know if I have heard from anybody else so far. So maybe describe what that is and how that fits more from the business perspective. So let's say if I'm a business person and really trying to figure out, okay, what the hell autonomous AI is and how I can take advantage of that. So what am I doing with it?
Yeah. So let's kind of back up there. So autonomous AI, the term is not widely known yet. It actually originated from Microsoft Research, and one of the gentlemen there who really wrote the book on this was a gentleman by the name of Ken Sanderson. He's no longer at Microsoft. He actually works with us now. But Ken wrote a book called Designing Autonomous AI. It's an O'Reilly book, and you can probably link to it in the show notes or whatever. But that book really kind of laid out the framework of this new approach of autonomous AI.
Okay.
And there's really kind of three key pillars, maybe a fourth, but the first one is deep reinforcement learning.
Okay.
So if your audience isn't familiar with that, it came out of DeepMind around 2015, 2016.
Yeah.
It kind of came out with a program called AlphaGo. That was their big coming out party. And AlphaGo played the game Go, which is an extremely complex game. Played it against our best grandmasters, beat our best Go grandmasters. They then went on to build AlphaZero. That beat our best chess grandmasters. They built AlphaStar. That beat our best StarCraft players.
Yeah.
So they were on to something, right? I mean, you figure AlphaZero went on to beat our best chess software too.
Yeah.
Like you figure that had decades of optimizations and strategies built into it, and it beat it using this new algorithm called deep reinforcement learning. Now, fast forward, many companies now are starting to apply deep reinforcement learning not to playing games, but to solving problems on the plant floor. So that deep reinforcement learning is a key part of it. It's not the only part, though. A second pillar is called machine teaching.
Okay.
That's where we take the expertise from your existing subject matter experts and we bake it in. Now, it's tempting to say, well, why bother? Why not just hook the deep reinforcement learning up to a simulator and just let it figure everything out for itself?
Yeah.
Well, part of the problem there is that's not even how we teach human operators.
Right,
we don't just hook them up to a sim and say, you'll figure it out. Like we say, okay, this is what we do, and here's the different strategies we employ. And if it's, if the line's running hot, we do this. If it's running cool, we do this.
Yeah.
And so we want to capture those strategies. Yeah. And by the way, for free, then we also get that thing that a lot of our customers are looking for, which is capturing their SME's expertise before they leave. Yeah. Because a lot of these folks are just a couple years from retirement. And so if we can capture that expertise from them before they walk out the door, that's such a key thing. So that's the second part. The third part is sim. So it learns by doing, not by data, this particular AI approach. So you have to have some place where it can play.
Okay.
Now, we know that most of our customers don't have comprehensive simulation of their process, but we can build those sims based on data. So as long as they have historical data, which many of our customers do, then we can use that historical data to actually build what's called a data-driven model. And then we can have the brain learn. The neural network is called a brain that when it's trained this way. The brain can actually learn against that sim.
Okay, so very interesting. So, we definitely need a little bit of business insights here in terms of, these are great technical explanations, I guess, in terms of what you are able to do. Overall, in terms of the machine teaching is the term that he used. And I don't know how machine teaching differs from any other forms of AI. So from business perspective, let's say if I'm doing, I don't know if deeper enforcement AI is going to be different from your machine teaching. So from the process perspective, what's the difference for me?
Yeah. So, and let's zoom out, because I guess I didn't really define what autonomous AI does. I kind of talked about how it breaks down from a technical standpoint, but what it does is different than the existing machine learning that exists today. So the existing machine learning that exists in the industrial space today is almost exclusively about predicting something. Predicting the final quality of a product before it's finished, predicting what, in the terms of predictive maintenance, predicting when a piece of equipment, how many days do you have until that piece of equipment is going to go down, right? We're predicting a value. That's not what autonomous AI does. Autonomous AI does, frankly, what customers want AI to do. It makes a decision. So it looks at the current state of the system. It says, here's the next most optimal thing you can do.
Interesting.
And it's not greedy in a way. So again, if we go back to the chess example, so imagine it was playing against a chess grandmaster and it comes up on a pawn. Now, should it take that pawn or not? Well, in a greedy sense, it would just grab that. Well, maybe that's the best move to make. But if you're trying to win the game, that may not be the most optimal move to make. So you got to remember, it's able to build long-term strategy. How could it beat our best grandmasters in chess and in Go? Unless it was able to build these long-term strategies that will win the game. So it can actually make what look like short-term non-optimal decisions because it's planning for a long-term optimal decision.
Okay, so very interesting. So I'm going to break it down it from my perspective, the way I understand. Okay, so predictive AI, when you are describing that, obviously that is going to augment data, form the data layer. If
Right.
you are going to have missing data, then it is going to somehow complete that and going to provide you data points so that you probably can make decision. Okay,
Right.
that was my understanding of predictive. Now we have the generative AI, which can generate text, images, videos, whatever.
Right.
That's number second. Now, are you suggesting that this is going to be third branch
It
of
is.
AI? Okay, so that's
Yes.
going to come in. Somebody's going to announce that. Is it going to
Yeah.
be another
Well, I mean,
open
it's
to
already
AI?
so. So deep reinforcement learning. And I forget his Andrew Ng. Is that his
Yeah,
name?
yeah,
The
yeah, yeah, yeah. Yeah, he's part of the industry 4.0 group,
AI
I guess.
leader, everyone knows him, that guy. Yeah. So he actually put a chart out, it was earlier this year,
Yeah.
of where he saw the impact of all these different technologies. And deep reinforcement learning is a separate bucket. So
Huh.
he had generative AI on there. He had what's called supervised learning, which is the traditional ML, which predicts a value.
Yeah.
And then deep reinforcement learning is a separate category. So it's already recognized as a separate category. One of the key insights is that when you contrast it to generative AI,
Yeah.
is generative AI is going to have a huge impact on humanity because it
Yeah.
solves a lot of knowledge problems. And we're
Yes.
faced with a lot of knowledge problems.
Yeah.
Deep reinforcement learning solves operational problems.
Hmm.
And on the plant floor, we tend to suffer more from operational problems than
Yeah.
actual knowledge problems. So that's where I think that now it's not to say that those two things are mutually exclusive. We
Yeah.
definitely are exploring these ideas of generative AI working with deep reinforcement learning and how those two could interact. We're looking at all that. But right now, that's kind of the distinction I see is deep reinforcement learning solves operational problems and generative AI solves knowledge problems.
Yeah, so very interesting. So I'll give you some more stories from my experience of my AI colleagues. I have had great experience chatting with them about AI and everything. I mean, these guys were creating algorithm, very sharp guy, PhDs. And one of the things that I noticed that they were not as salesy, okay? They were not as confident, okay? Whenever you ask them, okay, how confident are you with predictive AI use cases? Okay, let's say if I have some data and I am trying to ask you to predict something, how confident are you? Can I put my money on this? And they're like, no, I mean, I'm probably going to be 95%, 96%, 97. I can never tell you, whether I'm going to be confident on this or not, right? And one of
Right.
the things that I had noticed based on those conversations is the quality of data drives pretty much everything. Even when AI is able to make up some data, but still the foundation of data will dictate how qualitative your insight is going to be, whatever augmentation that you are doing on data. In general, when you look at the industrial scenarios, that's where you are playing and you are saying, hey, give me your data. I'm going to do this magic and it's going to make decision auto-magically. Okay.
Yeah.
Now the foundational problem, and the foundational problem really exists in the foundation. And we are talking about, if you look at things like ERP data, you have no idea, Brian, how bad it is. Okay.
I don't know. OT data can be pretty bad. So,
But I mean, yeah, I don't know. Sometimes the way data modeling is supposed to work, I don't know how much these algorithms rely on the actual data modeling. Because let's say even in the physical world, okay, if you modeled a human as a dog or dog as a human, it'll be a very chaotic world. I don't know what an algorithm can do when you are going to be mixing up things. When you go into the real data modeling world, that's what we see. People don't understand how to differentiate between a dog and a human inside these systems. Okay. And they end up just mixing those things. So do you see any sort of impact because of this? Because that's the reality of the data.
Yeah. So let's tackle that. And there's kind of two different things I would say to that.
Yeah.
One is that I would agree that the real world data is very dirty, and particularly in the OT space. I mean, it's highly siloed.
Yeah.
It's not correlated. It's not clean. You've got gaps in the data. You've got sensors that have drifted, which introduces noise in the signal and things like that. So there's all kinds of issues there. However, we're very good. We do this for a living, so we are very good at dealing with that type of noisy data and getting to a data set that we can actually use to build a model. What we just had a project that we're doing right now with a sausage manufacturer.
Yeah.
And so this is food and bev, and so they're making sausages. And one of the issues that they see is high moisture content, because the meat that's coming in, it's obviously it's going to vary in its moisture content. It's coming from pigs and cows and things like that. Right. So So the natural moisture content is going to vary. They're adding moisture during the blending process. So
Yeah.
they're trying to control for that, and it's very out of control right now. And so we're building them a brain to control for that. Well, the first thing that we did is what we call an exploratory data analysis. So this
Yeah.
is my first point, is that we do this first phase where we take all that data and we basically give them a go, no go. Like we're is it going to be, are we going to be able to build a model that
Yeah.
the brain can learn from with this data? Is the data complete? Are there sensors that we would need to add? And maybe we circle back in a couple months after the sensor's been collecting data. Now, in the case of that, we got through the EDA and we were able to determine, yep, we've got the data, we can build a good operational model. But there's another aspect to it. The second point I want to make,
Yeah.
and that's that DRL is really a different beast in that it can still learn in the face of noise. So let's assume that you could give me a perfect model
Okay.
of your process.
Okay.
Maybe it's a first principle sim, which we can use as well.
Yeah.
But it's a first principle sim and it's a perfect modeling of your process. I'm
Yeah.
actually going to introduce noise into it.
Okay.
And have the brain learn in the face of noise, because it
Huh.
has to be able to operate in the real world. In the real world, you're going to have sensors that fail. You're going to have sensors that give the wrong reading. So
Okay.
it's got to be able to learn to operate in the face of all of that. And deep reinforcement learning is remarkably robust in its ability to handle novel situations and still come to an optimal solution. So again, if we go back to its origins,
Okay.
if it's playing against a chess grandmaster,
Yeah.
it developed a ton of strategies during its training, but there's certainly going to be strategies that a chess grandmaster is going to pull out that it had never seen before, and yet it was still able to beat that. The only way that's possible is if it's able to handle novel situations and still be able to build optimal strategy, and that's what it can do. So even in the face of sensors that have gone bad or issues like that or noise, it's still able to operate and it's still able to. And like I said, I would introduce that noise during the training, even if
Yeah.
it wasn't present. So we don't have to have a perfect model, and even
Yeah.
if we had a perfect model, I would add noise to it to make it imperfect.
So very interesting. So I'm going to add one more layer, and this is contrasting with my personal experience, my personal fears, and you can probably tell me if I'm off here, I guess. So one of my personal challenges is putting this much automation in anything, I guess, that humans are not able to debug, trace in terms of
Right.
what is happening with the algorithm, to be completely honest. Okay.
Mhm.
So one example that I was going to give you is, we are working with one of the campaigns, ad campaigns. How hard could it be, especially for Google? Google is the company known for algorithm, right?
Yep.
Right now, they are at a point where we are not able to run one of the ads, and they are just not able to tell anything. The only thing you get in return is maybe your funding is low, maybe something is happening. They have no clue.
Yeah.
No clue whatsoever.
Yeah.
So if this is the state of AI, so let's say if AI is going to make some decision and we don't even know what's happening. So
Mhm.
how do you control that?
Yeah. Yeah. And so one of the things that we're constantly striving towards, as AI researchers, is this concept of explainable AI.
Okay.
So it's not enough for it to make a decision, but can it explain how it came to that?
Right.
Well, one of the advantages to autonomous AI, this particular approach, is that machine teaching we talked about.
Yeah.
So when we capture that expertise from those subject matter experts, we actually create like a graph.
Okay.
And so let's say, for instance, going back to, okay, so if this expert who's been running the line for a decade, if he or she's like, well, so if the line's running hot, I actually make these adjustments.
Yeah.
But then if the line's running cool, I make these adjustments. Or in the case of like oil refine, we have an oil refining customer, right? And so they'll talk about sweet crude versus sour crude, which really describes the makeup of the incoming crude. And so they'll say if it's sweeter, we do this. If it's a sour crude, we make these changes. We actually will graph that. Like that becomes part of the workflow. And then as the DRL is making decisions when we actually put it into production, it can tell us where it's at in the workflow.
Huh.
So we can see, oh, okay, you thought you were in sweet, you thought this was the case, this is why you made the decision that you did. So instead of it being a monolithic black box algorithm that you can't really tell what's happening, the machine teaching actually allows us to break it down into much smaller, more manageable pieces, and you can follow the reasoning of why it's in the.
Yeah, so very interesting. So let's go back to your comment related to, hey, give me your process. I'm going to introduce my noise in this, and I'm going to create this real world situation. Okay. So let's say if you're looking for that state of the process, right? And typically when we deal with our engagements, to be completely honest, okay, you never get one version of the process. Okay, if there are going to be 100 people in the company, you get 100 versions of the, because
Hmm.
nobody really knows how the process is working, to be
Right.
completely. So
Right.
number one, how do you find that one version of process in your experience? Okay, are you simply going to take out from somebody's head, or are you going to draw, or are you going to get data? Because nobody really understands the whole. I mean, we do change management for living, okay, and one of the aspects of the change management is consensus building. It's
Yes.
very, very, very hard. We are trying to,
Yes.
find the truth. Okay, please tell us, where you all are, but they just don't know, just because everybody has their own sort of story in their head, and they are simply operating the way they have operated. So maybe tell me, how do you come up with that process, the first process
Yeah.
that you need?
So there's kind of two aspects of that.
Yeah,
One of those is that in a lot of ways the data doesn't lie. So yes, the data can have issues and the data can have gaps and the data can, but when you look at it on a long enough time scale, the data doesn't lie. So we can build an accurate model of what the process actually does, what the equipment actually does from the data without having to even ask anybody. The data is
Hmm.
going to tell us how the equipment operates in, well, basically all cases, because if it was operating, it was hopefully recording that data. So
Yeah,
in pretty much all operational cases, we should have a record of that. But that's the first part. The second part, though, and this is the part that, again, a lot of AI vendors who come into this OT space don't understand the organizational change management, is we're actually sitting down with the operators. We're sitting down with the experts who know how to run this line the best, and we are extracting that information from them. So when it comes time to prove that we actually have not only that our brains can not only operate at the same level as them, but maybe even in a certain edge cases are outperforming some of their best operators, those operators are sitting right next to us and they're nodding, yep, I saw it happen. And we can always run it in sim first and make sure that we're proving it out in the sim before we ever put it into production. But those operators are right there at the table. So we engage those operators right from the beginning. We feel like those are the experts. And when you have that engagement right from the beginning, it's so much easier to get these things approved, because when their higher ups and their bosses, they're just looking for that the people they consider the experts on this process, they're just looking for them to nod yes. And we've been working alongside them for months at that point, and so they're fully bought in. There's one other aspect that we haven't talked about that I think is
yeah.
important, and that's that we don't ever put this into direct control right at the beginning. That would not be good. So what we do is we put it into what's called a decision support system. So when it first goes into production, it's the recommendations. We have to hook it up to the control system in a read-only sense, so it can see. That's
Yeah.
its senses, so it can see what's happening. But the decisions and the recommendations it makes go onto a screen, and then a
Yeah.
human operator is implementing those recommendations. So
Huh.
it'll say, turn this knob to here, turn this knob to here, and then a human operator is making those adjustments. We never start in direct control. However, we have customers, that refining customers one,
Yeah.
where after a certain kind of burn-in period, 6 to 8 months, where they
Yeah.
feel like everyone is confident that it's making the right decisions, they have every intention, they're not there yet, but they have every intention of hooking this up so that it can do direct control on the.
Very interesting. So, Brian, you are super knowledgeable guy. There's no question about that. Time flies when I'm talking to you. I think we are close to our time right now. Do you have any closing thoughts, closing advice for our listeners?
Yeah, I mean, again, I think that if you want to grow in this manufacturing space, you're going to have to embrace AI. And if you work backwards from that, you're going to have to make some investments in OT data infrastructure. You're going to need to start to capture that data. A lot of customers that I talk to nowadays are capturing data, but I still stumble on a customer once in a while that has not been capturing data for all these years. And it just blows my mind, because every second that process goes on and you're not capturing that data is value lost. So you want to be capturing that data. You want to build out an OT data infrastructure so that you can start to take advantage of these advanced technologies like AI. And you want to start on that journey now. The only other thing I would say, and I know it sounds self-serving, but I would get an independent SI involved, get a system integrator involved. If it's not us, find someone else that you trust, a company that you can work with. But we're going to have an independent voice. If you go right to the AI vendors, they have a hammer, and so all they're looking for is nails. Everything looks like a nail to them. So, because their product can only do so much. Whereas if you talk to an independent SI, I've got all kinds of vendors that I can bring to the table, and we can build a solution that crosses all the different systems that you have, and really truly is a single solution that's independent of any particular vendor's product that solves a problem for the customer. And so get an SI involved right from the beginning, and they can get you going.
Okay, amazing insights there, and thank you so much for that advice. My personal takeaway from this conversation is going to be that technology is definitely moving very fast at this point of time. So you need to move faster, I guess.
Yeah.
Faster from where you were. Obviously, you cannot move faster from technology because technology is at a phenomenal pace at this point of time. I don't know how next 10, 20 years are going to be, but it's just crazy.
Yep.
On that
Yep.
note, Brian, thank you so much for your time. This was a powerful episode.
Sounds great. Thanks, Sam. Appreciate it.
I cannot thank our guests enough for coming on the show, for sharing their knowledge and journey. I always pick up learnings from our guests, and hopefully, you learned something new today. If you'd like to learn more about Brian, head over to rovisys.com. It's ROVISYS.com. Links and more information will also be available in the show notes. Also, don't forget to subscribe and spread the word among folks with similar backgrounds. If you have any questions or comments about the show, please review and rate us on your favorite podcasting platform or DM me on any social channels. I'll try my best to respond personally and make sure you get help. Thank you, and I hope to get you on the next episode of the WBS podcast.
Thank you for listening to another episode of the WBS podcast. Be sure to subscribe on your favorite podcasting platform so you never miss an episode. For more information on growth strategies for SMBs using ERP and digital transformation, check out our community at WBS.rocks. We'll see you next time.